So hi, it's my second time ECC, the first time Cannes. I'm very proud to be here. I'm David Mühlbacher, representing the Rocklogic company, and we are talking about today about Fusaka, PeerDAS, and runtime metrics, and about this ominous StereumLabs. So, what is my today agenda? I mean, basically it runs for getting answers about Ethereum client behavior, but first of all, I want to say who we are, then what we did want to know from everything like that, and how we solved it, and how it might impact you, and then of course what you're waiting for Fusaka and PeerDAS metrics. So, who is Rocklogic? Rocklogic is a company that is based in Austria, is now ISO 27001 certified, and is running in the Lido curated set, and is so active node operator running day to day on production. And we are one of the few who run 37 client combinations, 6 execution layers, 6 consensus layer, and standalone Aragon Kaplan on bare metals with 90 days metrics. So we do this every day. But now I want to go into historic of Rocklogic, because so you can get what we did. What I want to say is what we first developed was Stereum launcher, and we wanted to empower the Ethereum community to spin up their own nodes in every client combination. You can use it. Then we invented Stereum Plus, which gave you the infrastructure to run it on if you don't want to go with the major companies like Hetzner and everybody else. And now we thought about, we could talk about Fusaka and peer metrics, and we will, no worries. But we want also to empower you to do such analysis, and that's how we came up with StereumLabs. So, if you're not a node operator, I have to say you something. It's not light truth. Getting answer about Ethereum client behavior is very painful, and if you do your analysis yourself, you have a lot of dashboards, you navigate dozen panels, you have to write queries, you have always asking yourself if you're looking at the right metrics, and if you're running actively at 3 a.m., you don't need, you need answers, not dashboards. So if a client ships client dev ships a new release, you always find yourself in a room with the same painful questions. Did it help or hurt? How many on how many AL pairings, and compared to what baseline? So here it comes, StereumLabs platform. As I said, we run all major execution layer and consensus layer combinations and one standalone Aragon Kaplan. And we have 20 plus dashboards that help you to monitor them and answer all these painful questions. We run them on isolated bare metal nodes. We make them real reproducible, comparable data. And yes, we got an Ethereum grant, so thank you very much for that. So, but the final thing is, but dashboards have limits, and it still takes a lot of time to compare all these metrics, even if you have good dashboards. And we wanted everybody to make clear or get to clear results, and that's where AI came in. So, what are you able now? You can ask now an AI chatbot to compare disk growth between Geth and Aragon over the last 30 days. You have the ability to check if the update of Prism what affected the resource usage. You can now ask how the memory changed on Lighthouse in the latest update. And this proper analysis, which with real numbers, don't take you days or hours, it is here in seconds. But as we see with AI, the question always is it just another vibe-coded, hallucinating AI set? And that's where the secret sauce in our company lies. We have a lot of experience in running nodes, and so we trained the AI model or had made the instruction so that you can really see which metrics matter for what combination. We also learned it to see normal ranges for pairing. So, for example, 3 GB in RSS for Prism and Geth, that's just fine. But Prism and Base, for example, this is a red flag, as you might know. We have also the metrics have client architecture differences. So for example, memory models. And of course, one painful thing, also the query sequencing, in which order you have to run the queries. Everything is answered by AI. And here's a proof. There is also a report we published just a few days ago. So if you want to scan it, it's a Chrome QR code, not hacked. Promise. And you can easily see, on average, the memory is minus 5.1%. The block processing is faster, the pure count is stable, and CPU is very mixed on depending on the combination. So, but is this enabling, or what is in for you as a node operator? What could we help you even more? And that is where AI alerting is coming in. Of course, we said normal alarming, so we have near real-time alerts, for example, the attestation rate dropping, for the disk usage exploding, for the pure count drop, but also for security reasons, and I will come back on that later. But of course, just having the stats and having an alert doesn't answer you why such thing is happening. So we implemented also an AI root cause analysis, so that it gives you over a webhook that is triggered by the anomaly a real explanation what you have to do, and not within minutes, but in 5 to 15 seconds. So, what is also very useful is, as we run all 37 combinations, is it gives you this baseline. So you can always answer with every question you're asking, is it happening to the whole Ethereum network? Is it just happening to this specific client version, or is it just in my local environment? And this could be also very helpful for security. So what we always also do is security monitoring. We do checks on every login. We do a restart analysis, which, for example, can make the change if, for example, the fee recipient changed. We would give you an alert. This can mean big money loss, and of course drift detection. So if your configs changes, I will warn you. So this brings us to the next question: how could this run on your system? How it will affect you? And of course, the one thing is to have it as software as a service, as a platform. I think that's right for researchers or for small node operators who want to come. I will tell you later about how you can onboard. But there is also a pull model, and maybe I have to enforce that we are ISO certificate, so it's very safe. We will scrap your data on your Prometheus endpoint, and your data will never enter our system. It's just on the AI interference level, so you will never have any trust issues. But if you have trust issue, there is even a more direct, full control way how to run it, and this is on-premise already running. You will get the entire stack in your infra. You get your own API keys, and your data will never leave your own network. So that's the third option. So what makes this unique? Of course, the coverage. 37 client combinations, I think that's nothing everybody else is running currently, and we are monitoring and analyzing it, and we have historic data over since September. Of course, the instructions set, which is based on years of staking knowledge since merge, and of course our security expertise, trained of course by the ISO certification, but also on a long experience on running nodes ourselves and dealing with every issue. Yeah, the current status, I think almost everything is running, and the rest is coming soon in Q2. So if you want to have access to AI alerting and security monitoring, yeah, just connect and you might get early access. So, okay. What I now, and now I'm coming to the thing you might finally came for, and it's just an overview of what Fusaka meant for the ecosystem, and we want to enforce you, of course, to do this yourself in the future, or if you have any more specific question to it. So, what are the results? The network RX dropped by 60%. The CPU raised in average by 30%. The memory is down 8%, and the discrete, as probably expected, is down half, so at a drop of 53%. So what we could say, in average overall, PeerDAS trades a modest CPU for massive bandwidth and I/O savings. So I think we can see this is a very significant cost reduction. Of course, on non-supernode pairings, I mean, it's the only thing we could compare. So here's some highlights, maybe for the consensus layer. Yeah, Nimbus is currently the most CPU intensive PeerDAS implementation. Lighthouse is the lightest. And Grandin and Nimbus have both a very significant memory improvement. On the execution layer, Bezo has has the most overhead, and Nethermind and is the only implementation that reduces CPU. And Bezo is a 35% drop in, also in EC memory. Okay. So, you can now connect with us, getting early access. What we are always searching for researchers that want to run in our infrastructure, old client teams, old client development teams, getting access to our model. That's based on the Ethereum grant. So if you're a client team, please contact and ask for us. Yeah, and then there is only one final question, and is what would you want to ask your infrastructure? Thank you very much, and if you want to connect, please scan the QR code. A small one. Okay. Okay, thank you very much.